All right, welcome to C Programming Skills using Replit. I'm Norman McIntyre. We're continuing on the Array of Games program. We started this on the previous lesson. So before watching this lesson, make sure you watch the previous one, and I'll show you how far we got on it from the previous lesson and then where we'll pick up on this lesson. So the Array of Games, the idea is we had a game 1, 2, and 3. And in the previous video, we got all the way up to game 1 and actually had it implemented where you could guess the ASCII character. What we're going to do during this lesson is focus on game 2 and 3, the ANSIC C reserve word, and also the tic-tac-toe game. So as a quick review, the skills you picked up from this is the modular programming. That is, we use lots of different files. We learned about the scopes of variables, things that are global scope that can be accessed anywhere, which are very rare. In fact, as I think about the program so far, we don't have any global variables at this point, and probably won't. It's actually pretty rare to have global variables with global scope. We have had several in file scope, where we have the variable hidden inside the file, and function scope, also called local scope, is when it's right there within the function and only within the function. So very briefly, in our array of games, we first, in the previous video, focused on doing the startup code. We had a main.c, a startup, a play, and a shutdown. And then we kept adding features to it. We added a menu option so it would display the different games. We made a game framework where each game was in a separate header file and implementation file. We then added a function called getTitle, where we can get the titles of the different games. We added a play function where we could actually play the game. And the one we implemented in the previous video was this version 0.5, where we could play the ASCII character game. So that brings us up to this lesson. We're going to focus on the ANSIC C game, where we display reserve or ask you to guess the reserved word we're thinking of, and also the next one is the tic-tac-toe. So with all that as introduction, let's get. So I'm going to flip here to my code. I'll go ahead and run it just to show where we were at from the previous lesson. So when you run the previous lesson, it displays this menu, shows us the things we can choose. If I choose -1, we simply exit. Or if I run again and I choose, let's say 0, to do the guess the ASCII character game, it says it's thinking of hex 33. So what is that from an ASCII perspective? It turns out it's the character 3, and notice it says correct. We could run the game again, and this time let's say I guess it wrong. It says 35, but let's say I think it was a 1. It says try again, and no, it's actually a 5, and correct. Now the ones we have not implemented is the guess of the keyword, nor have we implemented the, I see here we've got a copy paste error. I see I never changed the name of the tic-tac-toe. So I actually just saw that now. You may have seen it in a previous video. In any case, let's get to work. And again, I want to stress, I'm assuming you've already got the code from the previous video. If you don't, you need to watch the lesson 6, all the video playlist. Actually, I take that back. It might not be lesson 6. It was lesson 7, I believe, where it had the video playlist. So make sure you watch that. Okay, so let's make some changes. First, in my startup, my startup.c, I'm going to change this version. This is actually going to be version 6, so 0.6. Also, I realize in my tic-tac-toe game, I never changed this text here. It still has the guess the ANSIC game, so I'll do that. I'll say tic-tac-toe game. And this is very common, actually, believe it or not, in software development. A lot of times code goes out and there's some text that's wrong, some messages that need to be cleaned up, and it could be just like this. You could think our QA group was testing it and they said, hey, you've got two menu options that are the same. Whereas I was so close to it as the developer, I just kind of overlooked it. So that's why a QA, a quality assurance group, is important to always test your code. So our focus at this point, we've changed the version, we've changed this, and I would say next is to focus on this ANSIC C game. So within this ANSIC C game, what we're going to have is keywords. So we're going to have a static, in other words, we want to hide this, character pointer, because this will be words. I'll just call it keywords. Keywords are reserved words. So we'll say, and this will be an array, and this will be equal to the following. So I go ahead and put my open and close curly braces, go ahead and put my semicolon there. And I'll just list them here. We maybe won't use all of them, but I'll use a good many. So we know that break is a keyword. We know that case is a keyword. We know that certainly char is a keyword, right? We used it. We've used, I don't think we've used this one yet, constant, meaning it does not change, but I'll put it there because we'll certainly use it at some point. Continue, right? When you're in a statement, you want to continue in a loop. The default, in fact, really a good review is to just know how all these are used, right? At this point in the course, we've used most of these. So default, when we're in a switch statement. Of course, do, when we're in a loop, where we say a do while. There is a double, when we're doing double precision floating point. There's else, when you have a if-else statement. Enum, I don't think we've used this one. It's where you enumerate the values. So we'll, if we haven't used that, maybe we have, I actually don't remember, but you basically enumerate. I'll show one real quickly here. We could say type def enum, and I'll just say call this colors. I think we maybe have used this one, so colors. And you just list them out. I could say red, green, blue. And you now have a new data type. A lot of people like to put underscore T, meaning it's a new data type. So this thing called colors type literally has the values red, green, and blue. So that's what a enumerated type is about. You don't see them that often in C code. It was something that was added fairly late in the C language. A lot of people, instead of using enumerations, just do pound defines. But there is a place for them. They're certainly good. Maybe when you're writing new code, you might want to use enumerations, and we will cover them more. Here's another one I don't think we've used yet, extern, where you want to get extra. You're in a file and you want to access a variable that's declared externally somewhere else. So, but we'll more about that later. Float is single precision floating point. Of course, a for loop, we're familiar with that. Now this is one you rarely use. I don't think we've used it in the course. Go to, which says basically go to a different statement in your code. You see those very rarely, very, very rare. Of course, an if statement, that's probably one of the more common keywords. Of course, an int for an integer, another keyword. A long, for if you have the difference between int and a long is, the idea is they're both integers, but long, like on a 32-bit machine, an int would be 32 bits and a long may be 64 bits. Right? It could be, the idea is that you have two different sizes of integers, an int and a long. And actually we have other sizes as well, but for right now. Another one you rarely see, but I'm going to put it here just for the completeness, is register. This one we have not talked about, probably won't actually, is so rare. It deals with telling the compiler to put the variable inside a register if it can. It's kind of a hint to the compiler that the variables will be used a lot and it might be good to put it in register. Of course, return, we've seen that for returning from functions. Short, so this is another integer. The idea of short int and long, the idea is this would be smaller, this would be the next size up, and this would be the next size, so different sizes. Signed, we haven't used this too much, saying that you can give a signed integer and also an unsigned. You don't see that used too much because by default you have these signed values. But anyway, we'll keep it there. Size of, we've used this when we were dealing with arrays to determine the size of an array and also the size of a variable. Static, we know how we've used it a number of times. That keyword actually has multiple uses. We've used it to hide things inside a file. It also can be used inside a function to keep data around to make it static so it doesn't go away between function calls. Here's one we haven't used yet, and we'll cover it in great detail. I called a struct for structure. A lot more to come on that. Switch, we know when you have a switch statement, there is the type def. This is another one we haven't used too much. I used it actually right here. It's when you're defining your new types. We'll use that more when we talk about structures, but it basically allows you to create your own particular type definition. That's what it stands for, type definition. Union, another one we'll be covering later. A union allows you to put multiple size data types inside the same box, so to speak. So more to come on that. Unsigned, if you want to have an unsigned value. So numbers can be both signed and unsigned, right? Unsigned means there are no negative numbers. It's just 0, 1, 2, 3, 4, 5. Whereas signed means it can have negative numbers as well. And let's see, just a few more. Void, of course, we know stands for nothing. Shows that you're not returning anything, for example. Another one you don't see too much, but I'm going to put it here, volatile. This one's probably one of the, again, it's very rare you see this, except in certain cases. Volatile means, and let me spell it right. So volatile. This basically is, again, telling the compiler that the compiler may think the value does not change from where it looks at it when actually it's being changed externally from somewhere else. And don't worry about the details of that right now, but you see it sometimes when you're doing what's called embedded C programming, when you have interrupts that can come in and change a value outside of the main function. So that tells the compiler to be aware of that. And our last one we'll do is while. So those are all our keywords. I'll put a comma here at the end. This is a convention. I mentioned this in an earlier video. Some developers always like to end it with a comma, so if you add additional values there. So I'd say when we do this, when you play this game, I would say let's first I would say display. In fact, when you think about it, you say, well, wait a minute. This is similar to what we did in the ANSIC C game, in that we came here. Here we initialized the table. Then we got a random index. And then we printed some information. So you could say here, instead of initializing the table, we just want to display the table. We still want to get the random index, right? We still want to do that. So what I'll do is as follows. I'm going to say, seems like this is kind of common to what we want to do right here in this one, except I'm going to copy that and go over to the game.c. And when I paste it here, instead of initializing table, I'm going to say display the table. And then I still want to get a random index for which one we're going to be using, so I'll keep that there. And I'll put I want this to be a private function, this display table. Or I want this to be private, so I'll put that right there. It's not going to return anything. So we'll say void display table. and we'll come back to that. And of course this is going to be static, right? Hide it. We don't want it to be seen anywhere. And static for this get random, this guy here. And I could say, wait a minute, you know what? This code actually is the exact same code I already have here. Now, when you find yourself doing what I'm getting ready to do, the copy and paste of the exact same code, that means you should put it into a function in a separate file, because it's being used here and it's being used here, the exact same code. Now, I should do that, but since the focus here is really on using arrays as opposed to that, I'm just going to make you aware of it, that that's how I should do it. I should do it, but instead I'm going to just copy it from here. There's actually another reason, because it turns out we are going to change it slightly. So it turns out, even if I created a separate file just for this function, I've got an issue in that the way we were doing it for ASCII characters was offsetting it by 30. Whereas here in my game, this one, I'll just paste it here. Here the get random index is not going to have this offset. It's not going to have that offset. Also, this will be actually the size of the table. That'll actually be the size of the table. So with that in mind, you could say, well, how do you know the size of the table? Well, remember, we can say, but I'll break it up into two steps. I'll say int num table entries equals size of the whole table. So the size of these keywords. So keywords, the whole table, divided by the size of a single entry in the table. So keywords of 0. Right, keywords of 0. Make this a little bigger. So that'll give me the table entries. So that means here, instead of dividing by 10, I'll by the num table entries. And then that will return our choice. Of course, we see we got errors here, and we know why, because we're missing the include files. So I'll go ahead and include that. I'll say, well, we know that we're going to include standard lib.h. That takes care of the random number generator, and include time.h to give us access to that time function. So I'll come back down here. Now the warnings have gone away. Right, warnings have gone away. So I display the table. I'm going to get the random index. To display the table, here really the exact same thing. I could paste it right there. And again, this is another example. When you find yourself copying and pasting code, an alarm should go off if it's the exact same code at two different places. You should say, wait a minute, that should be a function. That should be a function. And in fact, in this case, we'll say we'll have a static function that returns an integer, and we'll call it get num table entries. And when you call this function, it's going to return this. It's going to return that. So that means here we could simply call our function get num table entries. Now, an important point to always realize, and this is another error I see students have a lot, you have to declare the function before you call it. So here, by putting it here, I call it here, well, it already knows what it is. And even here, if I have the same thing here, so you know I'm doing this same code, so let me paste it right there. Because it's declared here, I can call it here and I can call it here. An error I see students make is they will take this code and instead of putting it here, they'll put it down here. And notice when I put it down here, this is implicit, right? Implicit declaration, because it doesn't know about this. So make sure you declare your functions before you use them. All right, so we've got that taken care of. All right, remember you can pause the video, you can slow it down as needed. So we just need to display all the keywords. So when it says display the table, we'll say printf guess which keyword is randomly selected by, and I'm going to stress that you can let the compiler concatenate multiple strings by selecting one character at a time. In other words, you're going to enter, for example, an E, and it'll tell you whether you've selected it right. You'll see more as we implement this. So that'll print that out. Then when it comes time to print out the table, we'll say for integer I equals 0. Remember the index, the starting index here is always 0. So for it starting there, for I less than the num table entries, right? We want to do all the table entries in I++. And what we'll do for each one of those is just do a printf, the value of the table with a space. We'll put a space there. And say we want to do the keyword of I. And that are actually keywords of I. Cool. And then maybe after we go through all that, we'll do a printf, a \n. So that'll display our table. Let's give it a run. We've typed in a good amount of code. So this is the guess the ANSIC C keyword. So I'll do one. Guess which keyword is randomly by selecting one. Looks like I need a space there. By selecting one character at a time. So the idea is we need to guess a character at this point. Of course, we need to get a random index, and so just for debug purposes, I'll say printf our random answer is %d. Right, this is for debugging purposes, and we'll say what is our answer, and then we'll printf our random keyword is %s, right, a string, and that would be we go to our keywords and we have we index using our answer. Right, we index using our answer. So I'll click on stop, click on run. I'll do a 1, and notice it said our random answer was 19, which happened to be short. Right, the keyword short. So that's cool. So we know that. Now for this play, we know we want you to enter some number of characters, right, to guess guess the letter. So what I'll do here, I'm thinking I want to say do, maybe we'll print out and say printf. Well, actually, we'll do it like this. We'll say do while, we'll say playing. So while we're playing, as long as we're playing the game, and we'll say, well, we're going to have an integer called playing equal to 1, meaning true. So while we're saying, we'll say printf select, I'll say enter a single character. I guess thinking about it, I could make this game. I'm thinking we got two options. We could have you select a character at a time, or we could have it where you type in the whole word. So looking at this, if we select a character at a time, each time you enter a character, we could show the current list, filter the list based on which character you entered. That would be one option. Or we could ask you just to enter a guess. And I think as I'm pondering which way would be best for this particular lesson, I think we'll ask you for the whole word. We'll say, what keyword am I guessing? And we want you to enter a keyword, right? So we'll have a character keyword. And when we look at our keywords, we see that no keyword is longer than, say, 10 characters, right? Like continue 1, 2, 3, 4, 5, 6, 7, 8. That's probably the longest there is. So we'll say keywords can be 10 characters, right? 10 characters. So when we say what keyword am I guessing, the idea is you're going to enter it. So we'll do a scanf into, we're looking for a string, and we want it to go into the keyword. Right, we want this to go into a keyword. And this will be keyword of 0 is where we want to put that. You can either write it like this. Let me show you two different ways, because I find this, I get questions on this keyword. Either one of these is correct. In fact, I think I'll comment this one out. An array is a pointer to the first entry in the array. And that's why either one of these works. Because a variable array is actually a pointer. So here we said this index of 0, take the address of that. Well, it turns out it's even simpler just to say, do it like that. Now once we do that, we'll say if. And here we're going to have to use a string function. And remember, we have a whole lesson coming up on strings. But I'm going to say string compare. I believe we use this in some other videos. String compare of the keyword that we entered. Compare that to keywords of the answer. And if that is exactly equal to 0, if it's exactly equal to 0, so if I compare the keyword we entered to the keyword that the answer, if those are equal, then I'll say printf you win, \n, and I'll say playing is now equal to 0, else printf try again. String compare, Implicit, what do you think by now? Header file. So we go and add, we go up to here and say, yeah, we're going to add a include string.h. So here's our play code. Let's run it. Just give it the what I call the smoke test. Okay, we'll do 0 or we'll do 1. Okay, what am I guessing? Now, the reason I keep this here because we know, right? We know in this case is guessing index 3. So I can go 0, 1, 2, 3. So it's guessing constant. So if I type in constant and press enter, we win. Right? We got it kind of easy. Let's do it again. I'll click on 2 again. This time I'll say, no, actually I want to do 1. In fact, let me, to be at the top of my screen, let me start over. So I'll say 1. Now it says 12. So let me purposely choose the wrong one. I'll say break. Try again. So notice we could put a new line character there. So where it says try again, printf, try again, \n. What keyword am I guessing? Oh, well, 12 would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Looks like the 4. I'll say 4. You win. All right, we got it. So obviously there's more we could do on this. We could clean the code up, and actually you should do so. You can certainly do that if you'd like. But definitely make sure you've got at least what I've got here. We now have 2 of these games implemented. In fact, when I run it, let me start over again. I could choose the game 0, where I guess which character. I see 38. We know that's decimal 8. So correct. And I could do game number 1. And I could guess. It says, oh, here the answer is 26. So I'd have to go all the way. What? Maybe that's maybe while. Try again. Maybe volatile. I don't know how far 26 is. I just keep going back. Try again. How about unsigned? How about union? I guess I should have. Oh, it was union. Okay, so you win. And then -1 to exit. Okay, I'm Norman McIntyre. Thanks as always for watching.